Here's another feature that is offered by EMR with respect to Iceberg. EMR offers FSS Lustre as a temporary storage where you can store your metastore. And the reason for that is Iceberg maintains metadata across multiple small files like metadata file, manifest file, and so on. And this is to effectively do things like pruning data or filtering data or reading the correct snapshot, merging delta files, and so on. And Iceberg has implemented fast scan planning to make sure that the metadata file operations don't take a large amount of time. But this time taken is slightly high for object storage like S3 because of the higher read and write latency, especially in use cases like high throughput streaming ingestion, application writing to an S3 data lake in near real time. Many snapshot files are produced in micro batches at a very fast rate, and this results in a high number of snapshot files. And obviously, it causes degradation in the performance of the metadata file operations, especially on the reader side. So that is the reason why we have this feature. So here you can see we are using Kafka as a source, and we are ingesting data into the S3, into the EMR, and we are writing to the Iceberg table. And as usual, Glue will be used as the data catalog. And also, we'll be using S3 to store our Iceberg metadata and Iceberg data. So this is as usual. However, here, what we are going to do is we are going to create an FSS Lustre file system, and we are going to mount that file system on top of the EMR, and we will be using this to also update the metadata asynchronously to the FSS Lustre. So the reads from your Iceberg table, the reads that request metadata will be served, those requests will be served by the FSS Lustre. And the write requests will be served by your metadata and your data on S3. And only if the data is not found on Lustre, it will go to S3. So that way, your readers will be able to work fast because they have their metadata on a more optimized file system. And as usual, you can scan the QR code here you see on the left to look at the GitHub repo, which will have all the commands and the instructions that we're going to run. And before we start the demo, this is just an example architecture. This is not what we're going to do exactly, but I'll be showing you how you can create FSS Lustre and use it with your EMR for Iceberg. I have some example notebooks for you to run, but I am going to run Iceberg batch operations on a notebook because I also want to dive deep on all the features that are available in Iceberg, like schema evolution, partition evolution, and so on. So this demo is more of a two-in-one. We'll be doing an Iceberg dive deep into all the most important features of Iceberg. And we'll be using EMR cluster to run those commands backed by the FSS Lustre file system to store our metadata. So that's it. We'll move on to the demo. So these are the steps that needs to be performed. I'll go from one. So the first one is you need to create the FSS Lustre file system, and you need to select the Scratch deployment mode. And I've already created it here, and I've just kept pretty much everything as default. And if I go inside this, and only thing you need to choose is you need to choose the VPC and the subnet that you're going to launch your EMR cluster in. You can launch a cluster in a different subnet, but that will lead to cross-AZ traffic, which will have impact on both performance and cost. So it is better to have your cluster created in the same subnet as your FSS Lustre. And once you create your FSS Lustre file system, it's going to give you the DNS name and also the mount name, right? And what we're going to do is we're going to use these two values to create a bootstrap action. And this is the bootstrap action. And what this bootstrap action will do is we're going to use this bootstrap action when we create the cluster. So when we create the cluster, it's going to create a mount point on our EMR, and it's going to use our FSS file system. And this is our FSS DNS name, which you can find from the summary tab here. And you can also replace your mount name. So this is my mount name here. And I provided this bootstrap script as well in the GitHub repository that I shared. And this is where your, in this mount point is where your metadata will be asynchronously updated from S3 so that the reads will be served from this place. So now we'll use this to create an EMR cluster. And for this feature, you need to create an EMR cluster of at least release label 6.9. So I already have one created here. And here, if I go to the configuration, as usual, I'm using Glue Data Catalog for Hive and Spark, and I've set Iceberg enable to true. Now, if I go to the Bootstrap action, you can see this is the Bootstrap I'm using. No arguments. I'm just providing the script that I showed you, which is there in the GitHub repo. All right. And this is the hardware configuration. If you're interested, I'm using 15M5 8X large cores and one M5 8X large leader. But you can use a smaller instance type also. It's not like I'm using any heavy operation. So it's okay to use smaller type. But I already have this cluster up and running, so I used it. So now you have a few options. You can either SSH into the cluster and use Spark SQL or Spark Shell with the Lustre and Iceberg dependencies to run your Iceberg job. Or you can, to make it easy, what I have done is I've used EMR Studio. You can either use EMR Studio, or if you go to the left-hand side pane, you can see the notebooks here. You can create a notebook. Right? You can create a managed notebook, and that will take you to a Jupyter Hub or Jupyter Lab, whichever you prefer. And you can create a notebook and you can work with it. And I've also uploaded this particular notebook to the GitHub repo as well. So you can just upload this and you just need to change your S3 bucket name. That's about it. Everything else, you can just leave it as is. So this is the script that I wanted to share. This script will basically go through all the important Iceberg operations. And I can also run streaming jobs on top of this. It's not like I need to run only batch jobs. In fact, the FSS Lustre is best run for streaming workloads. But since in another demo, I've already shown you a streaming example using Glue, I wanted to provide you a different example where we are doing the dive deep of all the functionalities available for Iceberg. And this is the most dive deep, like Iceberg basic functionalities overview that you're going to get. So let's get started with the instructions that you see in the notebook. I've already run all these notebook cells to make it easy and to save some time. So I'm just going to walk you through the contents and the output. So here first, we are using the configure magic cell to configure some Spark configs. And here, what we are doing is we are setting the Glue. We are setting our catalog basically. So here we are using the Glue catalog. You can see the Glue catalog implementation. And the most important thing is the IO implementation. We are using the FSS Lustre S3 file IO. So this is the one that is supported in EMR, right? And you need to use at least cluster 6.9. And like I said, this cluster needs to be launched preferably in the same availability zone as your FSS Lustre. Even otherwise, it will work, but it will be much slower, which is not what we want. And you provide a warehouse path here and your FSS mount path. So these are the options. You can find this in the notebook that I have uploaded. So now let's go ahead and create the Spark session. Whenever you run spark.version or anything to do with Spark, right, it's going to automatically create the session and the yarn application for you. And this is backed by EMR on EC2, but you can also run, you cannot actually run this on EMR on EKS. You can, but you kind of need to do it in a roundabout manner. I'm not sure if it's possible actually. So let's just use EMR on EC2 here. So here, let's come down. Let's go ahead and create our Iceberg catalog. So I'm going to use the catalog that we specified in the Spark configs. And we're going to create a schema called SalesDB and switch to that. And you can see the current namespace is SalesDB. Now we're going to create an Iceberg table. I'm dropping a table if it already exists, and go ahead and create the table. These are just standard commands. The main thing here is we are using the Iceberg, and we are partitioning it by the order date time from the days, right? And I'll show you how it looks like. So now when I do show tables, you can see the table orders has been created. Now, if I look into the snapshots of this table, I don't find anything, and that is okay because we haven't really done anything. We just created the table. So now let's go ahead and insert our record. So this is the first record we are inserting. And if I select star from the snapshots, now you can see the first snapshot, and you can see the number of records added is 1. And it also says we performed an append operation. Now let's insert 4 more records. And when we do a select star, you'll see 5 records, 1 plus 4. And if you select from star from snapshots, you can see 2 snapshots. We did first insert, and then we did the second insert where we inserted 4 rows. So you see 4, and you can see the record added is 4, and here is 1. Now the count is 5. The next is we're going to do deletes, especially this is useful for GDPR CCPA use cases, which we saw in a different demo in the streaming context. But here, let's see, like if you're going to run GDPR as batch pipelines, this is how you would do it. So you can delete a particular record from this customer. So we are just going to delete based on this condition. And we'll verify that 1 record got deleted. The record where the order ID equal to 2, it matched, it fell under these conditions, so it got deleted. Now, when you do a select star from snapshots, you can see there is a third operation that just got added. This is the delete operation, and a record had been deleted. And we can also query the manifest tables. Iceberg offers a lot of system tables, and it's really, really very useful. So if we query the manifest tables, you can see this is the last snapshot, like it's in the descending order of like the latest change we made, and it's in the descending order of that. So you can see the last change we made, we deleted 1 file, and the existing file count is 3, and you can see all these values. Now the count is 4 as well. And the next one is update. These are basic operations, but I'm just giving you an overview, but we'll be going into much more advanced use cases. So next is the update one. So we are updating a value where order ID equal to 5, and you can see the value quantity has been updated to 10 where order ID equal to 5. And when we query the snapshots again, you can see here an overwrite operation, and we overwrote 1 record basically. So that's what you see. The next is upserts. You can again, like what we are going to do is we're going to do a batch upsert. Upsert is basically delete, insert if the record does not exist, or update if the record exists, right? And the best way to do that is using merge into. And I've already used merge into for a different demo, but you can look into this time as well if you want to do it as a batch pipeline. So here you can see I'm creating a table, order update, and I'm just using CTAS. So this is not an Iceberg table. I'm just using CTAS to create a table here. This will just mirror our orders table that we've been working with so far. Now, what I'm going to do is I'm going to insert 2 values. And you can see the 2 values that are here. Now, what we're going to do is we are going to merge the 2 values that we inserted into the orders update, and we're going to merge it into our original or source orders table. And this is exactly what I meant. So if the record does not exist, then you would insert the record. If the record exists, then you would update. This is called upsert, right? This is how you would perform batch upsert. And if you also want to perform delete on top of this, you need to set a flag. So if the delete flag is set to white and the record already exists, you would delete. Otherwise, you would update. And I've shown that example to you when we worked with the DMS. If you can go back to the YouTube playlist and you can check out that video, that recording as well. So now when we select, you can see the 5 records, and you can see the order number 99 and 3. This is coming from our the upsert operation that we did here. So here you can see the 3 and the value, whatever, the 3 already existed. So this one got updated in our original table, and this one got newly added. That's upsert. So now when we do a select star from orders.files, which is again a different system table, and this gives you a lot of information about the underlying files of your tables. And it tells you like what is a file format, what is a partition, and what are the file sizes, record counts. So a lot of information about your data files. And even null count. So it's very easy for you to do data quality check as well if you want to. Now, moving on to schema evolution, Iceberg really helps with evolving data sets, right? Whether your data set schema changes, or let's say column name changes, or the data type changes. So all of these will be accommodated by Iceberg, and I'm going to show you how. So here first we're going to rename a column QTY to quantity, and we've been able to do that here. And if I query from snapshot, again, this is what we see. And you can see the quantity. Again, when we do a select star, you can see the changes, whatever alteration we made has been successfully applied to the table. Now we're going to add a new column. Here I'm going to add a column called discount. And you can see that that column actually wouldn't get added. For that, you will need to do a describe because we haven't inserted any records yet. So this will only show the non-null columns. If there are any columns with fully null values, it will not show. So here, if I do a describe though, right, you can see the discount column that we just added. Now, when we do an insert, here I'm inserting an additional column, 0.1. This is our discount. Now, when I do a select star again, you can see the discount, right? It's null for all other values, but for the last one, it is 0.1, which we inserted. So next, we're going to drop the column. And here, I'm going to drop the discount that we just added. And when we do a select star, you can see the discount is gone. And again, you can see the snapshot to see what we have been able to change and how many records got added, removed, and so on. Here only one record, right? Because we only had discount for one insert. Now let's look into incremental and time travel querying. Let's look into time travel. So time travel is basically point in time query. Like how did my table look like back in May 2020 or 2 days ago? So this is a very common use case. And for that, you will need to query a previous snapshot. So we're going to get all the snapshots from our table, Iceberg table, using the snapshot system table. And you can see the different snapshots here. So what we're going to do now is we're going to run, we're going to use just the array and we are going to go to the state of the table after the second snapshot. So for that, you will need to use 0, 1. I'm sorry, 1, 0. Now here, this shows you the table, how our table looked like as of this time, right? And that's what we provided here. We provided the as of time, and we got this snapshot time from the above array. And you can see like we had order ID 99 and everything, right? You don't see that here because we are querying a snapshot that is in a previous state. Like we are not looking at the latest state of our table. We are basically time traveling to how our table looked like before we ran the merge into and all of that. And you can time travel to any given snapshot and see the state of your table for different snapshots, like snapshot, third snapshot or fourth snapshot. And you can also directly use your snapshot ID to query, and that's what I'm doing here. Last time we used the timestamp, which is also very useful. Like you don't have to worry about what's your snapshot ID. You can just provide a timestamp and you can see how your table looked like around the timestamp. Or you can also directly provide your snapshot ID like we are doing here. And we are providing the first snapshot ID 00, right? This will take us to the first change we ever made to the table, which is we inserted only one record. After this, we inserted 4 additional records, if you remember. So this is the first insert we ever made to the table, and that's what you're seeing here. And you can also query the system table called history, and that's going to give you all the changes, going to tell you whether this particular snapshot is the ancestor. If it's ancestor, this is the first change we ever made. And after that, we made several other changes, and you can see who is the parent for that change. Next is partition evolution and hidden partitioning. It's also one of my very favorite features, and it's pretty important as well, and it's very immensely useful, especially for many of our enterprise customers and finance customers who have evolving schemas and partitions. So first, let's look into the partitions. We created a partition called a date time day, and this is what we have here, just year, month, date. So now when we look at the S3 location of where our data is stored in the S3, you can see this is how it is being partitioned. Order, date, time, day, and you can see what's going on here. And this is basically one day, right? And that's the reason why you have one folder per day. So let's say 1 year down the line, we realize that we need to add hourly partitions. Like you need to query every hour. Let's say like your analyst requirements have changed, like or data volume has drastically increased, that doing just daily partitions is not enough. You need to like get even deeper than that. So for that, if you use traditional Spark, you will need to rewrite the entire data set, right? So you need to like rewrite your data set with the new partition scheme. But here, Iceberg allows you to add partitions without having to perform any data movement. And that's what we are doing here. We are adding a partition field, and we are taking the hours from the order date time, not just the days. So now after we do an alter table command, we added this partition field, and we look at the S3 location again, we continue to see the old partition. So there is no change to the old partitions. You can continue to query your table as you were querying your old data, right? Now let's insert some record into the table so that you will see how our hidden partitioning works. So here I'm inserting this again, and the last one is the current timestamp, which should be our partitioning field. And we will be taking, like earlier we were only taking the date out of this, now we will be taking the hour as well. So here you can see, if I go to the data, you can see the order date time day, which is our original partition. And now if I do an LS on one of the dates, like I'm doing an LS on the last date, and you can see the record, the folder, the prefix that got added, and you can see the order, date, time, hour. And this is the hidden partitioning. You don't even see it from your table perspective. Like you don't really have to worry about it. You're just inserting as you're normally doing, right? You're just inserting using the timestamp. But under the hood, your Iceberg is able to pick the hour, and it's able to create a prefix based on what hour it is. So it created a prefix for the 13th hour. Because if I do a date you now, it may be like late. It's 14 now. So I ran this like 1 hour ago, and that's the reason why you see 13. This is in UTC. Right now I'm at the 14th hour UTC. That's the reason I ran this exactly 1 hour ago. So now let's do a select again. And you can see, right? You can just query the table as you normally were. The beautiful part is you are able to add this partitioning field in your where clause and get the benefits of the partitioning here. So here I'm selecting where hour of the order date time equal to 13, and it's going to show you this because this is the prefix that got created. So any new data you add henceforth, it will have the year, month, date, and hour partition. But what if you want to query the old state of your table? You can still do that. This hidden partitioning doesn't affect your existing data set whatsoever. You can continue to query your data set as you used to. Only when you insert new records, it's going to be able to create prefix in the order of year, month, date, and hour. So querying system tables, I already showed you a few along the way, but just to recap maybe. The first one is history. So history will tell you what are all the snapshots you have and what are the parent snapshots. The first one doesn't have any parent because that is the ancestor. And you can see the other ones, and you can also see at what time those snapshots were created. Next is the files. Files is also very useful. In fact, it tells you what is a format, like what is a partition, and what is the size, what are the column sizes, individual column sizes, and what are the counts of values. Are there any null values? This also helps you do basic data validation. Otherwise, you will need to use a framework like DQ, but this helps you do it as just so you can just look into the system table and see if there's any anomaly that you want to look into. The next is manifest. Manifest is also a very useful table. So it just tells you like what are the existing file counts. If you've added a new file or removed a new file, removed an existing file, it's going to tell you about it. And a cool thing about Iceberg is you're able to join two or more system tables to get what you want. So in this case, I'm actually joining the history table with the snapshot table. And what I'm joining for is I want to get the Spark application ID along with the snapshot ID and what operation performed and when it was performed and so on. So you can see how useful it is. I can actually drill down to the Spark application that actually performed the operation or created the snapshot. And it also tells you like this is the application that did delete. This is the application I did append. Right? In my case, all the applications are same because I'm using the same Jupyter notebook, which means I'm using the same Spark session and same Yarn application. But in traditional or in a production scenario, this will be different application IDs. So one application will do delete, one will do append, one will do overwrite. So it really helps you to do things like auditing. You can see who made what change at what time. And before we go to the last use case, I want to show you. So all the commands that we ran so far is on top of the FSS Lustre backed cluster. And that's where your metadata will be stored asynchronously. So as and when you perform a write, you are able to check the FSS folder. So this is our mount point where it points to the FSS Lustre file system. And it in turn maps to the S3. And